Now, first of all, guys, the first type of matrix here is the square matrix. So as its name, I know that the matrix is a rectangular collection of numbers. Now here, a square matrix means that in this case, in this type of matrix, I have that the number of rows is equal to the number of columns, which means m is equal to n. Now guys, try to do any matrix that is a square matrix. You can do A22, you can do A33, A44, A55. Now what if I ask you to give me a square matrix of size 1 by 1? Think about it. A square matrix of size 1 by 1 is basically the scalar number. Yes, any number, any scalar number could be negative number like -1 or -5 or -100 or 100. Any scalar number is basically a square matrix because it is in fact a collection of one number, one row, one column. So it is a 1 by 1 matrix, and this matrix is a square matrix. Okay, so a square matrix is basically a scalar number. Now what is a column vector matrix? A column vector matrix means I have a matrix where all the elements are grouped in a column, which means that the number of columns is equal to 1 and I have several rows. Now basically guys, a column vector could be what? Could be, in physics, the velocity. So the column vector is basically any vector grouped in a column matrix or in a column. Example, the velocity, guys. So the velocity v, let's say, is equal to what? It is equal to vx, vy, and vz. So basically this velocity grouped in a column, or it is called a column vector, since all the elements of this velocity are all grouped in a column. Alright? I know guys that there are a lot of examples in your mind for a column vector, like for example the acceleration, the position vector in statics, the pressure. They are all grouped in column. I can also group them in a row vector, like the acceleration, for example, ax, ay, az. So this is also a type of matrix where the elements are grouped in a row, which means the number of rows is equal to 1. Now, as I said, a scalar matrix, which is also a type of matrices, it is basically a square matrix with another additional requirement, which is m is equal to n is equal to 1. So I only have one row and one column. A null matrix is basically a type of matrices where all the elements are equal to 0. This doesn't mean, guys, that the matrix has a 0 size. No. It has a size of 2 by 3, like this example, of 3 by 3, of 1 by 2, of 2 by 4. However, all the elements of this matrix are equal to 0. Like for example, if I want to do the subtraction of 1 from 1, 1 minus 1 is equal to 0. 0 is a null matrix, but it is a special case of this null matrix where I only have one row and one column. Now, what is a diagonal type matrix? A diagonal type matrix has the first requirement of a square matrix, so it should be square. M should be equal to n, with another requirement, which is that all the elements are equal to 0 except the diagonal side. But guys, pay attention to this note. When I say the diagonal side in a matrix, this means that this is only the line going from left to right. Alright, so it is from A to C here. Okay, I cannot say that this line 0b0 is also the diagonal line in matrices, alright? So when I say it is in the diagonal side, this means that it is in the diagonal line going from left to right, alright? So here, guys, another example or another type of matrices. It is called diagonal, which means all the elements are 0 except the diagonal side, and it should be a square matrix. Another very important type of matrices is called the identity matrix. And basically, guys, the identity matrix will be used in the inverse operation. So it is very important to understand what is an identity matrix. An identity matrix basically has the first requirement of a square matrix. So M should be equal to N in identity matrix. I cannot have an identity matrix of different number of rows and number of columns. So the number of rows should be equal to the number of columns in an identity matrix. This is the first requirement. The second requirement is that the identity matrix is a diagonal matrix. So Aij is equal to 0 for any i's different than j. So an identity matrix should be a diagonal matrix. And the third requirement is that the diagonal elements are all equal to 1, like this example right here. So this is an identity matrix, and it is a very important matrix because it will be used later in the inverse operation, as I said. So guys, if I want to ask you to give me an identity matrix of size 1 by 1, it is called basically I11. So what is I11? I11 is basically 1. 1 is a scalar identity matrix. And you'll see, guys, how this one could be used in the inverse matrix. Now, if I want to do I22, I22 is basically 1, 0, 0, 1. So this is I22. I33 is given here in this example. I44, you should add 0 here, 0, 0, 0, 1, and 0, 0, 0, 1. So it will have 4 rows and 4 columns. The last type that we'll talk about in this video lecture is the symmetric matrix. The symmetric matrix has the first requirement of a square matrix. So in order to be symmetric, it should be square. And the second requirement is that Aij is equal to Aj, which means if I have an element in the second row, the first column, it should be equal to an element in the second column, the first row. A21 is equal to A12, A31 is equal to A13, A14 should be equal to A41. So if you flip the column with the row number, they should be equal. So at this example here, so you can see I have B here, B here, C here, C here, E here, E here. Only the diagonal side is unique because in fact it is A11. So A11 is equal to A11. Doesn't make sense. So it is only unique in the diagonal side. So these are the types of matrices. I can say that the most two important types are the square matrix and the identity matrix because they will be used later on. In the next video, we'll start by the matrix operation. Thank you.